Hey guys, welcome. In this video, we'll look at how to factor a difference of squares. So a lot of times you'll need to factor something that looks like this, x squared minus 25. So what's the strategy for factoring that? Well, it's just remembering this simple pattern or simple rule, which is that anytime you have a square minus another square, that's why difference of squares, right? That's all this means, is that we're taking a difference of two squares. It's going to factor into this pattern a plus b times a minus b. So when you have a squared minus b squared, it's going to be a plus b times a minus b. So we can just apply that directly right over here. X plus 5 times x minus 5. Now, if you want to convince yourself that that's true, you can just use the FOIL method for multiplying binomials to multiply that out and see if you end up right back over here. So I invite you to pause the video and give that a try. Okay, so did you end up back here? So let me just FOIL that out right now. X times x is x squared. X times negative 5 is negative 5x. Positive 5 times x gives us plus 5x, and then 5 times negative 5 is going to be negative 25. Now when we simplify by combining any like terms, these two guys cancel out, and we just end up with x squared minus 25, which is right where we started. So think about it. Why do these signs have to be different? Why does this have to be a plus and that have to be a minus? It's so that these middle terms will cancel out. And I'll just quickly run through these examples. Just applying the pattern, this will be 3x here, and square root of that is 4, so we're going to have a plus 4 and a minus 4. In this case, we have a GCF we have to take out first, because 4 is a common factor for both of those. So we're going to have 4 times quantity x squared minus 9, and then we just apply our pattern. So it's x plus 3, x minus 3. So always remember to look for a GCF in all your factoring problems. And just one more thing I want to mention, because this is an area where people commonly make a mistake. It is so tempting, and it's a tempting mistake. We want this to factor. It looks like it should do something, right? We've got a square and another square. We really want it to factor. So they will try this thing, and I'm just going to write a big not equal sign to show that I don't mean this is going to work at all. This is because this won't work. But we want to factor it into this. I see many of my students wanting to do that. But then I always say, hey, let's multiply that out and see what we get. Well, x times x is x squared. X times 5 is positive 5x. This 5 times x is another positive 5x. And then 5 times 5 gives us positive 25. Now we can simplify this one and combine like terms. We get x squared plus 10x plus 25. See, these two are not canceling out. We aren't getting rid of anything in the middle. So this sum of squares will not factor. Now I do have to put in a little notation about this. When you get into like the second semester of Algebra 2 or maybe in pre-calculus, there's this magical sounding thing called imaginary numbers. And it does let you do something with this kind of expression, but you have to wait till you get there. So that's just a little something to look forward to in your future math life. But in the meantime, this is your pattern for factoring a difference of squares. So have fun factoring, and thank you as always for watching.